Hello everybody, I'm Maria Pozzi, and in this presentation I will talk about two different grasping strategies that exploit environmental constraints to perform robust grasps. Here are three different examples of hand-environment interaction. We have a soft hand interacting with a rigid environment, then we have a rigid hand or gripper in this case that is interacting with a rigid environment, and then we have a rigid gripper interacting with a soft environment. We will focus on the cases in which the interaction is intrinsically safe thanks to the fact that there is a soft interface between the hand and the environment. In the first case, we will show different strategies that allow soft hands to exploit the environment to grasp objects. We devised two strategies to implement the so-called slide-to-edge grasp. In this type of grasp, an object is dragged towards the edge of a table and then it is grasped from the table thanks to the fact that part of the object is protruding from it. The first strategy is called continuous slide and grasp. First, the hand is placed over the object to create a large contact patch with it. This is possible only because the hand is compliant. Then the hand drags the object towards the edge of the table and then, as you will see in the video, the hand will actually grasp the object by enveloping it with the fingers. This is possible only because the hand is protruding from the object and also because the hand is compliant. As you can see, there is a lot of interaction between the hand, the object, and the environment. This strategy was found to be very successful with thin objects, while it fails when the objects are taller. In the second strategy, two different motions are combined. In the first one, that is pivoting, the hand is placed over the object so to allow a rotation of the object with respect to the hand. The more the hand presses the object, the less the object moves. So based on this, the object is dragged toward the edge of the table in a desired configuration. After that, the hand can be placed in order to grasp the object. So this is the regrasping phase. This strategy works well for taller objects and for quite heavy objects. We trained a neural network that, based on the object's characteristics, can distinguish which strategy is the best. In the second work I will talk about, we present a device that is called SoftPad, that is a soft layer that enables a soft and safe interaction between a rigid gripper and the environment beneath the object to be grasped. The SoftPad is a matrix of pneumatic modules made of silicon. Each module is connected to a pressure sensor, and based on pressure variations, we can actually detect when an object is placed over the SoftPad. In addition, we can also estimate the shape of the object based on which modules are contacted, and we can also estimate a center of mass of the object. Based on this information, we can place a gripper over the object and then grasp it. The SoftPad also provides another type of information. In fact, we will see in the video that when the gripper touches the SoftPad, then the gripper starts closing. So the SoftPad also allows to detect the contact between the gripper and the environment. So let's focus on the case that we saw in the video. In this case, the object is touching the SoftPad in two modules. So the first thing that we have to do is to detect these two modules. Then the center of mass of the object can be estimated based on the differences of pressures in the modules. In this case, the center of mass is a bit towards the edge of the SoftPad, to the bottom edge of the SoftPad. Then the orientation of the object can be estimated, and based on this, we can compute the center of grasp and the angle of grasp. In this case, the center of grasp will correspond to the center of mass, whereas the angle of grasp will be perpendicular to the object orientation. Based on the number of modules that are in contact with the object, we can extend the procedure that we just saw to other objects that are even more complex or bigger. We tested our algorithm with 11 different objects and we got a success rate of 94.5%. As you can see in the slide, the SoftPad allows a rigid gripper to grasp objects that would be impossible to grasp if they were placed over a rigid surface. We have seen two different grasping strategies that exploit the soft hand environment interaction in a complementary way. They can be used in different applications depending on the available sensors, on the available robots, but also on the objects to be grasped. In the first case, we used a hybrid force-velocity controller, relying on visual and force sensing data. In the second case, we have built a soft device that provides sensing capabilities and softness to the environment. Thank you for watching the video from all of us. If you want to know more, please check our papers.